Good morning. In order to address the question that how I solve nanofabrication process issues in my career, I have chosen two examples, one from my PhD and second in my current role at the ANU. Before I explain these two examples, I would like to mention that electron beam lithography is used in both cases to address nanofabrication. I would also like to emphasize that electron beam lithography, or in short EBL, is a vital tool to address nano device work because the diffraction limit is not a problem at all, as is the case for optical lithography, and it is maskless as well. That makes it most flexible. Proximity effect is a well-known phenomena in electron beam lithography. It arises due to the excess electron dose, which is the amount of charge per unit area delivered to the neighboring elements due to backscattering. My PhD research was focused on the photonic crystal structures and used these structures for nano devices. In order to quantify the proximity effect, or PE in short, I have fabricated photonic crystal waveguides. During the electron beam lithography step, I have changed the number of neighboring rows for different waveguides and exposed them with the same amount of dose. In optical characterization of these waveguides, we could see a clear trend with the change in rows. In fact, we determined the sub-nanometer change in the photonic crystal waveguide features, and the finding was presented in Applied Physics Letters in 2011. The second example that I want to present is related to the overlay, where I have to mix and match layers on the same device. Nanowire is a key research area in the Department of Electronic Materials Engineering at the ANU. This department is biggest user of ACT node of Australian National Fabrication Facility. I was consulted to make nanowire based lasers where the light could be coupled in and out by distributed feedback effect. Essentially, I have to develop a scheme to fabricate DFB nanowire lasers. In order to achieve this goal, we dispersed nanowires on a patterned substrate that has the coordinate system with accuracy better than 20 nanometer. Nanowires were trapped in the coordinate system, and the electron beam lithography automation using automatic mark scans is used to place the first order grating on the nanowires. The SEM micrograph of DFB nanowire lasers is shown in my application for this job. In achieving this task, we had to overcome a complication, which was that nanowire used to displace with respect to the grating during the processing. I have introduced a conformal coating before performing first order grating, and this approach has increased the yield of DFB nanowire lasers. With this, I would like to thank for watching.